Have you ever just looked around at, well, everything and wondered, what is all this stuff really made of? I mean, the chair you're sitting on, the water in your glass, the air you're breathing, it's all so different. But what if there's a secret ingredient connecting it all? Well, today we're going to find out.
I mean, our world is just full of all this incredible variety, right? Think about it for a second. Why can you stack stones on top of each other, but you can't stack water? And why does the air around us feel like nothing at all, but it can totally fill up a balloon? It's like every single substance is playing by its own set of rules.
And all these little questions, they all point to one huge central mystery. And that's what we're going to try and unravel today. What is the fundamental stuff that actually makes up everything, from the ground beneath our feet to the farthest stars in the sky?
Okay, so to get to the bottom of this, we've got to change our perspective. We need to think small, like really, really small. Let's start by just taking a normal, everyday object and see how far we can break it down.
Our whole investigation is going to start with this, a simple stick of chalk. I'm sure you've seen them 1,000 times. It's solid, you can write with it, it's kind of brittle, but believe it or not, it holds a major clue to our whole mystery.
So, first things first, the obvious move. We can just snap it in half. Now we have two smaller pieces of chalk. But here's the thing to notice, it's still chalk. The stuff itself hasn't changed one bit, just its size.
But hey, why stop there, right? Let's take this even further. Let's grind these pieces down and down until all we've got left is this really fine powder. So we've gone from one solid stick to literally thousands of tiny microscopic grains.
Okay, now this is the really important part. If we could zoom in on just one single speck of that powder, what would we see? You guessed it, it's still chalk. No matter how much we crush it or grind it, we haven't changed what it is. And that tells us something huge. There must be a basic building block, a smallest possible piece of chalkness that you just can't break down any further, at least not by crushing it.
And that brings us to our very first big clue. These fundamental building blocks have a name, of course. Scientists call them constituent particles. It's a bit of a fancy term, but the idea is actually super simple. All matter, everything you can see and touch, is made up of a truly mind-boggling number of these incredibly tiny particles.
So clue number one, everything is made of particles. Got it. But you know, this idea, it actually creates a brand new puzzle for us, and we can see it play out in what I like to call the case of the disappearing sugar.
Okay, so watch this. We take a spoonful of sugar, we dump it in a glass of water, and you can see all the little crystals sitting right there at the bottom. But then you give it a quick stir and poof, they're gone. Now the water definitely tastes sweet, so we know the sugar's still in there, but where did it go?
Well, it didn't vanish. The sugar just broke down into its own tiny little particles so small they were able to slip right into the empty spaces between the water particles. And that reveals clue number two. Matter isn't a solid, continuous block. It's actually made of all these particles with tiny little gaps between them, which we call interparticle spaces. All right, so let's recap. We've got tiny particles, and we've got tiny spaces between them. But that brings up a pretty obvious question, doesn't it? If everything is just a collection of little loose bits, what's stopping the entire world from just crumbling into a pile of dust?
The answer is our third and final clue: invisible forces of attraction. You can kind of think of them like tiny little magnets constantly pulling all the particles toward each other. And the strength of these inner particle attractions, that's the master key. That's the secret that unlocks this entire mystery. It's what decides if something is going to be a solid, a liquid, or a gas.
And now we have everything we need. With our three clues, particles, spaces, and forces, we can finally solve the mystery we started with. It's time to put it all together.
So, let's start with solids. Let's go back to our piece of chalk. How do our three clues explain why it's so solid? Well, in a solid, those interparticle forces are incredibly strong. They pull all the particles into this tight, organized grid, and they lock them into fixed positions. The particles aren't free to just wander around. The most they can do is just kind of vibrate in place.
And that tight, rigid structure, that's exactly why solids have a definite shape and a definite volume. You can't just squish a rock into a new shape because its particles are all locked arm in arm by those really powerful forces.
Okay, so what about liquids then? This is where it starts to get pretty cool. What happens if we just turn down the strength of those forces a little bit? In a liquid, the forces are still strong enough to keep all the particles huddled close together.
but they're not quite strong enough to lock them into that rigid grid anymore. This lets the particles start to slip and slide past one another. And that freedom of movement, that's what we call flow. And that's exactly why a liquid takes the shape of whatever container you pour it into. The particles just flow around to fill the available space. But since those forces are still keeping them packed pretty close, liquids still have a definite volume.
And finally, we get to gases. So what do you think happens when we take that dial for the attractive forces and we turn it all the way down to basically zero?
Well, in a gas, those attractive forces are so incredibly weak, they're barely even there. There's really nothing holding the particles together at all. They're completely free to just zip around at high speeds, bouncing off each other, and just spreading out as far as they possibly can.
So there it is, the whole story on one table. The real difference between a solid, a liquid, and a gas isn't what they're made of. It's just about how tightly their particles are holding onto each other. Strong forces give you a rigid solid. Weaker forces let the particles flow as a liquid. And pretty much no force lets the particles just fly apart as a gas. It's one simple principle that explains so much about our physical world.
And that kind of leaves us with a final, really powerful idea. See, the world isn't made of solid stuff and liquid stuff. It's all made of the same fundamental particles, just governed by forces of different strengths. So if changing those forces is the key to changing the states of matter, it just makes you wonder what else could be possible if we could learn how to control them. Thanks for joining me for this explainer.